Today we're going to be solving systems using augmented matrices and row operations. So a system of linear equations can be represented using what's called an augmented matrix. It uses the coefficients and constants and puts it in a matrix. So we ignore the variables and we put it in an augmented matrix. So what we do is we take our coefficients, so 1 and 3, and we put a line, and then our constants, and then 2, -1, 3. So that's going to be our augmented matrix. So the coefficients go on the one side, and then our constants go on the other side. Sometimes you'll see that vertical bar drawn, sometimes you won't. Okay, so when working in an augmented matrix, there are some legal moves that you can make. So you can swap rows, totally legal. You can replace a non-zero multiple of that row, so you can multiply by any number except 0. And you can replace a row by the sum of that row and a constant multiple of another row. So you can multiply a row and then add it to another row. Okay, then we have some notation that we use. So we number the rows, row 1, row 2, row 3, row 4. Sometimes you see it as a subscript, sometimes it's just next to it. Depends on how lazy I get as to whether I use a sub or just next to. So sometimes you'll see a row 1, sometimes you'll see me do row 1. They mean the same thing. Okay, you can swap rows. We do the little arrow saying we swapped them. If we multiply times 4, we just say 4 and then row 1. If we add them together and we multiply, so like -2, row 2 plus row 1. The last row in the operation is the one that will change. So if we say -2 R2 plus R1, that means that R1 is going to be the one that changes. I like to add a little bit of a notation. I say -2 R2 plus R1. That's going to become my new row 1. That just helps me remember where exactly it's going. So that's how I write my notation. It's not wrong if you don't. Okay, here we go. So it says carry out the indicated row operation and write the new augmented matrix. Okay, so 1/3 times row 1. Okay, so what we're going to do, that means that every number in row 1 gets multiplied by 1/3. So our new matrix is going to be 1, -3, -3, and then row 2 does not change. Okay, so we could say, well, that's going to become our new row 1. Our example B, we have our matrix, and it says -2 times row 2 plus row 1. That is going to become row 1. So we're going to multiply here by -2. When I do that, I get -4, +10, +8. And now I'm going to add that to row 1. So -4 plus 1 is -3. 10 plus -3 is 7. 8 plus -3 is 5. And then we keep our original row 2. And our last one, 3 times row 2 plus row 1, that's going to give us a new row 1. So if we multiply by 3 on row 2, that gives us 0, 3, and 6, and we're going to add that to row 1. 0 plus 1 is 1, 3 times -3, or 3 plus -3, excuse me, is 0. 6 plus -3 is 3. And then our bottom row does not change. Okay, so a lot of times when I'm going through, I find it helpful to write in different colors. So if you have different colors, utilize that. When I'm doing like the little side operations, I like to write my math down because I lose track, especially when multiplying and then trying to add. I get confused. I get confused easily anyway, but if I'm writing all that extra math down, it was really, really helpful. All right, so to solve an augmented matrix, we use row operations to change the coefficient matrix to the identity matrix. The identity matrix is when we get 1s down our main diagonal and 0s everywhere else. and then we get constants in that constant column. Okay, now what we want to do is follow a particular order to get that. So our first thing we're going to get is a 1 right there. Then our second goal is to get that 0. Then we're going to get our 1 there. And then last, we're going to get that 0. So we're going to work counterclockwise going through. Okay, so let's do a couple of these and work, see if we can get that solved. Okay, so I want to get a 1 in that upper left corner, and I see a 1 in the bottom left corner. So I can swap row 1 and row 2. So row 1 and row 2 are going to just swap places. So when I swap places, I get 1, 3, 5, 2, -1, 3. So step 1, done. I got what I needed. Now I need to turn the 2 into a 0. So I'm going to have to use a multiplication add to get there. So I'm going to do 2 times row 1, -2 times row 1, and I'm going to add that to row 2 to give me my new row 2. So when I multiply by -2, that gives me -2, -6, and -10. Like I said, I like to write in a different color just to keep track. So when I bring this down, I'm not changing my row 1. What's changing is row 2. So -2 plus 2 is 0, which was my goal. -6 plus -1 is -7. -10 plus 3 is -7. Okay, now my next goal is to get this guy to become a positive 1. So if I multiply by -1/7 times that row 2, I'm going to get what I need in row 2. So we're not changing row 1 yet, but row 2, we're going to get what we need by multiplying by -1/7. 7 times, or -1/7 times -7 is 1. Okay, so we're almost there. Now I need to turn that 3 in row 1 into a 0. So that means I have to multiply and add. So I'm going to multiply row 2 by -3. And I'm going to add it to row 1 to give me my new row 1. Okay, so when I multiply, I get 0, -3, -3. Okay, the thing that's not changing is row 2. Now row 1 becomes 1, 0, 2. So that gives me my solved matrix, because if I were to rewrite this back in an equation form, top row, that means 1x plus 0y's equal 2. Bottom row means 0x's plus 1y equals 1. So in other words, x equals 2 and y equals 1. Now, we have solved using substitution and elimination. You're more comfortable with that, so you're like, come on, just let us do it that way. Nope, we're working with matrices, so you've got to solve it using a matrix. Okay, let's do another one. Here we go. I can't just swap rows. So this time, let's multiply the top by 1/10. So 1/10 times row 1 gives me row 1. So that gives me 1, -1/5, and 3/5. Fractions are going to be easier to work with. I know you probably don't believe me, but really, really they are. Okay, and then we didn't change anything in row 2. Now we need we need row 2 to get a 0. So now we're going to do 5 times row 1 plus row 2 to get us what we need in row 2. So let's multiply the top by 5. So that gives us 5 and -1 and 3. So now row 1 doesn't change. And row 2, we get 0, 0, 0. So we can't now get a 1 right here, right? There's no way to turn that into a 1. So let's think about what happens if we turn those back into equations. Well, we get something funky in that top row, but in the bottom row, we get 0 is equal to 0. 0 equals 0 means what in math? Right? We have 0 equals 0, which is a true statement, so this means that there's an infinite number of solutions. All right, it says solve the system using an augmented matrix and row operation. So first thing we need to do is write an augmented matrix. So first, let's turn this into an augmented matrix. So 1, 2, 4, 1, 1/2, 4. Okay, so we already have the 1. Now we need a 0, so we're going to just do -1 times row 1 plus row 2 to give us row 2. So that's a weird looking 2. We're going to multiply the top by -1. So that gives us -1, -2, -4. So when we add those together, our top doesn't change. Our bottom one, we get 0. And then -2 plus 1/2. So that's -4/2, so that's -3/2. And then 0. We need to turn -3/2 into a 1, so let's multiply by -2/3, the reciprocal. So we're going to do -2/3 times row 2 to give us row 2. So row 1's not changing. Okay. Row 2 changed. Now we're going to do -2 times row 2. We're going to add that to row 1 to get row 1 because we want to turn that into a 0. So when we do that, that gives us 0, -2, 0. So we get 0, 1, 0 in our bottom line, and our top line becomes 1, 0, 4. So our solution is 4, 0. So that one wasn't terrible. Could be worse. Could have been better. Could have been no solution on the second line. That's always better. All right, now this one, we're not quite in the right form to be able to write our augmented matrix, so we need to solve this one and get it in the right form. So we'd have -5/2 x plus y equals 1. Now we can put it in our augmented matrix. So we have 5, -2, -7, -5/2, 1, 1. Sorry, I don't like that negative. I'm closer to my 2. There we go. Let's multiply our top row by 1/5. So 1/5, row 1 becomes row 1. So when we multiply that by 1/5, we get 1, -2/5, and -7/5. -5/2, 1, 1. Now we're going to multiply by 5/2. So 5/2 times row 1 plus row 2 gives us row 2. So when I multiply, I get 5/2. And then 2/5 times 5/2 is 1, so that would be -1. And then 5/2 times -7/5 would be -7/2. Okay. So when we add those together, again, our top isn't changing. Our bottom, we get 0, 0. Well, -7/2 plus 1 is -5/2. And this means 0 equals -5/2, which is not true, so this has no solution.